Supply chain. Context and perspective. The supply chain can discover patterns and trends in the past shipment data to help predict future needs, prevent disruptions and stockouts, and better manage the company's inventory. The objective is to evaluate the relationship between the sales based on its sales per customer, order item total, order item quantity, and order profit per order. At the end of the study, the factors contributing to the sales, how the sales per customer, order item total, and order profit per customer contribute to the sales should be identified based on the dataset will be the expected results. So next is organizational understanding. The goal is to better understand how supply chain can affect each category. The researcher recognizes the factors that will contribute to the customer's sales, order item total, and order profit per customer, and believe that by investigating the relationship between a number of those factors, the relationship would be able to understand the performance of each category. To do this, the researcher used correlation as a way to model the relationship between the factors that will be investigated. The researcher will use correlation as it is a statistical measure of how strong the relationships are between attributes in a dataset.
So for the data understanding, for the first attribute is late delivery. This attribute could be a binary variable that indicates whether an order was delivered late. And second, this order profit, it could refer to the profit that the company makes on each order. It could refer also to the total profit that the company makes. So for the third one is the order item total. This attribute could refer to the total number of items ordered by a customer. So for the sales per customer, about this attribute could refer to the average amount of money that each customer spends per order. So for the days for shipment, these attributes refer to the number of days it takes for an order to be shipped from the warehouse to the customer. Benefit per sale. This attribute refers to the profit that the company makes on each sale. It could also refer to the benefit that the customer receives from making a purchase, such as free shipping or a discount. And next is day for shipping. This attribute is similar to the days for shipment, but it may refer specifically to the type it takes for the shipping carrier to transport the order from the warehouse to customer. So for the last one is sales. This attribute refers to the total amount of revenue generated from sales during a certain period. So for the data preparation, the following steps that I will discuss are done to prepare the data set for correlation. The first step is download the data set from Kaggle and rename it based on the required file name, which is dataset.csv. And the second step is upload in a Python directory. And the 3, observe the value of each attributes. Fourth step, check the dimension of the data. And the last step would be check if there are any missing values and cleanse the data. Do the data processing and display at least 3 times data visualization.
In this report, I will interpret the histogram representing various attributes of our dataset. Each histogram provides insight into different aspects of our business operations, helping us understand patterns and trends. So let's proceed to the first attribute, which is days for shipping. As we can see in the histogram, the majority of orders are shipped within 2 days and some of the orders are shipped with 3 to 6 days. So the histogram shows that the company is generally efficient in its shipping process since most orders are shipped within 2 days. So next, um, next attribute, which is the days of shipment. As we can see in the histogram, majority of orders are scheduled to ship within 4 days, followed by 2 days and 1 day, and 0 as the lowest. Overall, the histogram suggests that the most shipments are scheduled within a few days of the order being placed, with 4 days being the most common scheduling duration. Additionally, there are there are also a significant number of shipments scheduled within 2 days and 1 day. So next attribute is the benefit per order. As we can see in the histogram, 0 has a highest bar, which means almost of the orders result in no profit or loss for the company. So, next attribute is sales per customer. As we can see, the peak bar is found within the 0 to 500 peso bracket, suggesting that this price range is the most frequently encountered sales category among individual customers. So, next category is late delivery risk. Based on the histogram, it shows that majority of deliveries have high risk of being late, but some of the deliveries have a low risk of being late. Next attribute is the category ID. As we can see, the highest bar is found between 17 to 24. So the histogram suggests that the most popular product category ID is ranging from 17 to 24, followed by products that has a category ID ranging from 40 to 45. So let's proceed to the next attribute, which is the order item quantity. As we can see, the highest bar is found at quantity 1, which means most of the order contain 1 item, and orders with 3 or more items are less frequent. Next attribute is sales. And based on the histogram, the most frequent sales range appears to be between 0 to 300, with a bar height that's visibly higher than others. This means there were more sales that fell within this range than any other. Next attribute is order item total. Based on the histogram, it appears that most orders in this dataset have relatively small order items totals. However, there is a small but significant portion of orders with much higher totals. So let's proceed to the last attribute, which is order profit order. Based on the histogram, there are many more orders with profit between 0 and 500, and it appears that most orders in these datasets are profitable. However, there is a small but significant portion of orders that results in losses.
The x-axis, this represents the value of the variable being analyzed, which in this case appears to be order profit for order. And the y-axis, this represents the probability density, which is shown as continuous curve. And the higher the curve at a particular point, the more likely it is for a data point to fall within the range of values. And the color gradient this helps to visually distinguish between areas of high and low density. So in this case, it seems that blue represents lower density and yellow represents higher density. And the small peaks, this represents individual data points. So however, because the plot is a density plot, the data points are not shown as individual dots but are instead smoothed out to create a continuous curve. By comparing the blue and the green lines in the graph, you can see how each processing step has improved the performances of the model. So if the green line is higher than the blue line, it means that the processing step has had a positive impact on the target variable.
First, let's discuss modeling. The correlation matrix was created in Python as correlation coefficients will be used to measure the strength of relationship between each possible set of attributes in the dataset. Because we have 10 attributes in the datasets, our matrix is 10 columns wide by 10 rows tall. All other pairs of attributes will have a correlation coefficient of less than 1. Correlation coefficients will fall somewhere between -1 and 1. And that concludes the descriptive modeling using correlation matrix that our group did. So now let's discuss the evaluation based on the modeling that we do. So considering the relationship between the order items total attribute and the sales correlation coefficient is 0.99. This indicates that they have a very strong positive correlation. The positive correlation indicates that one attribute's value increases, the other value attribute also increases. But positive correlation also means that as one attribute value decreases, the other attribute value also decreases. The negative correlation exists if one attribute value decreases and the other attribute value increases, and vice versa. So another evaluation that our group cite based on the modeling that we do is that the relationship between sales per customer attribute and the sales. So their correlation coefficient is 0.99. This means that they have a very strong positive correlation. So the positive correlation indicates that as one attribute value increases, the other attribute value also increases. But this also indicates that as one attribute value decreases, the other attribute value also decreases. And a negative correlation exists if one correlation value, one attribute value decreases and the other value increases, and vice versa. So, another evaluation that our group cite based on the modeling that we do is that the relationship between all the attributes and the order item total correlation. All their coefficients are within the range of -0.0 to +1. Therefore, the absolute coefficient has a very weak strength, or simply they have no correlation at all. The correlation of 0 means that there is no relationship between the two variables. In other words, this means that as one variable moves away, the other variables also move to unrelated direction. So lastly is the deployment. So deployment is the recommendation for the researchers. So the data set includes information on sales per customer along with other relevant attributes. One key observation is that the strong positive correlation coefficient of 0.99 between the sales per customer attribute and total sales. This correlation suggests that a highly relationship between the average sales per customer and the overall sales figures. Based on the results, the recommendation that we can provide is that the company or the business should use their customer data and purchasing history to find items or services that can sell more. In that way, companies can increase their sales per customers as well as their total sales.